The next thing to know about programming is that there are a lot of programming languages out there. So I'm going to teach you kind of how you can learn more about programming if you want to learn more about programming, and make some suggestions or recommendations about what you should learn and how you should learn it and where you could go to learn it, all for free, or at least some of the resources I'm going to point you towards are going to be free. So there's just a crap load of programming languages in the world. If you go to Wikipedia and search for a list of programming languages, check it out. You know, many lifetimes to learn all that. Yet in here you will find, you know, we were looking at PHP. That was just one language, and you saw how that was like confusing. So anyhow, there's a lot of programming languages in here. And when we talk about languages, there's actually 5 levels of language. They get categorized into 5 levels of language. So at the bottom, first level language, we have machine language, which is nothing but zeros and ones. Second level language, we have something called assembly language, which is a little bit of a step up from zeros and ones, but still really hard for humans to understand. Third step up, we have first machine language, zeros and ones, computer speak, and then we have assembly language. And then we have the third level languages, which are procedural languages, which we've already sort of talked about, procedural programming. And most programming languages fall into this procedural programming category. Even the object-oriented programming languages, it's all considered a third-generation language, and third-generation languages are considered procedural languages. And then we have fourth-generation languages, which are like structured query languages like SQL, right? So SQL, structured query language, SQL, SOL. Yeah, that's SOL. So SQL, structured query language, I'm not even seeing it here, but that would be a fourth-generation language, so maybe they don't consider that a list of their programming languages. There's T-SQL, right there, transaction SQL. So, and here's an example of what that looks like. Yeah, so that's for accessing databases, fourth generation language. And then finally, we have the fifth level languages or fifth generation languages. And fifth level languages are what we speak. They're known as natural language. So we have machine language, assembly language, procedural languages, structured languages, natural language. And this is what we speak. This is what machines speak. And this is what we program in most of the time. So we have to get what we program in down to what computers speak. Because ultimately, for a computer to understand anything, it needs to be zeros and ones. So we write something in a programming language, right? Third generation language. And when we're done writing it in this third generation language, we have to translate it down to machine language. And so there's a special piece of software called a translator or a compiler, or if you're using this language, an assembler. And those translators, compilers, assemblers will take what you've written in this third generation language and turn it into zeros and ones. And so the people who put together the programming language know how to take that language and turn it into zeros and ones. And you just use a piece of software, a compiler, assembler, a translator, use that piece of software to turn it from the third generation language into the machine language, which computers need to understand. And then that would be considered an executable, right? And it'd be something a computer would be able to execute. So there's a whole bunch of languages out there. And once you've written it in third generation language, you need to compile it or translate it or use an assembler to get it down to your object code, right? And the language you wrote it in would be considered source code, and object code would be the zeros and ones. All right. So if you wanted to learn about web programming, you would need to learn HTML5, CSS3, PHP, MySQL, and JavaScript. Those are the languages I would recommend that you learn right off the bat. And to learn those, I've already pointed you towards this resource. But you should go to Muroc Books, and you should get their book, Muroc Books, Web Programming Books. You should get their book, HTML5 and CSS3. You should get that book and start out there. And then after that, you should learn, in this order, PHP and MySQL. That would be the next book, which is sitting right here on my desk. And then after that, you should learn JavaScript. And these books are all fantastic. And while you're learning CSS, you might also want to go to lynda.com. And there's some great titles in there about CSS and HTML5 to help you learn that. And you know, that's like that's 1 year of learning right there to work through all those books and those courses and to get those down. That's 1 year, and you'll be able to make basic websites at the end of that year. But at a really great level, like you should be able to make a little money making websites for people if you apply yourself a couple hours every day to learn these things. At the end of 1 year, you'll be there. Other learning resources that are out there, you know, there's this right here, Weebit.net. Actually, if inside Blackboard, there's a list of a whole bunch of resources which I think are good for you to know about. And so I'm just listing them right here. I'm actually going to change this window so they all show up a little bit more in a paragraph block so you don't have to scroll across the whole screen. So here they are, and you can just pause the video right now and read through this list of resources and go check them out. But, you know, Khan Academy, Coursera, lynda.com, edX, Duolingo, Harvard University has an extension, Harvard Education Extension. These are all great resources to look at. So just, you know, pause the video and read these resources. And here's weebit.net. So if you want to learn a little bit more about like programming apps and things like that, you should come here and you should take their intro course, take the C course, take an intro to object-oriented programming, take their C++ course, and then you could go into Objective-C, and that will enable you to be able to write applications. So you have a little bit of learning to do there. That might be one way you could do it, or you might just, yeah, you know, go and start learning about web programming, but this, or app programming, but this would be the more thorough route, so you kind of have an understanding of it. Like the intro course here, what's it say? It's 4 hours long, and then you take the C class, that's 11 hours long. Then you take the intro to object-oriented programming, 2 hours. Then you take C++, 12 hours, and then you take Objective-C, and that's 12 hours. You know, and so then, yeah, you'd be well positioned to learn about mobile application development. All right, so those are some resources to learn more about programming. What else do we have to say about here? Last thing I want to say is that when you do create programs, you want to use good program design. And there's a few tools out there which I feel compelled to tell you about because they're always in the textbooks for introductory computer concepts course like this. And those tools are flowcharts and pseudocode. So basically all a flowchart is, just so you're familiar with it, a flowchart just basically, you know, diagrams logic, right? So here's a flowchart for who knows what. But, you know, this or that, and we saw flowcharts when we talked about flow control, right? When we talked about flow control, what did I call it? When we talked about flow control structures, that's what I'm leaving off. Flow control structure, right? So here are some flowcharts right here: sequence, iteration, selection, flowcharts. So flowcharts are used not only for kind of diagramming, you know, the flow control within a computer and how it reads programs, but also for structuring the logic of, you know, here's some process, some system, and this is the way decisions are made, and we needed to sort of capture that and understand it so that we could then program it. And another thing programmers will do before they actually write the program in the programming language, they'll use pseudocode. And pseudocode is just basically, you know, what the program logic's going to do, but it's just sort of written out. It's a tool, translates actions to directions, many steps, right? And here are all the steps. So that's a little bit of pseudocode. Often pseudocode looks a little bit more like this, right? Where it's not the real language yet, but it's just sort of written out about how we're going to write it when we eventually do it. And a lot of people don't do any of that, and they just do something called iterative coding, which means they just start building it and then test it and then fix it and then test it and then fix it and then test it and then fix it. It's another way to do it. All right, so that's a little bit about programming and some resources for you to learn more about it, and the languages, programming languages, and the 5 generations or 5 levels of languages: machine language, assembly language, procedural language, structured language, and natural language, what humans speak, and compiling and translating. Good stuff.